Good morning, this is Dr. Turner for Integrated Math 3. Today we're talking about 3.2, which is multiplying polynomials. This is something that technically we've seen before in the distributive property. We're going to look at examples where we're doing a little bit more than just a monomial times a binomial, but we'll get to that here in just a second. So, multiplying a monomial times a binomial is pretty straightforward, and we've already seen examples of this where we use the distributive property and we multiply what's outside into each term that's on the inside. So for instance here, I have 3x times 2x, and I have 3x times 6. In doing this, you need to make sure you are following your rules of exponents, which if you need a reminder, that's back in Unit 1, so you can see it there. That's really all we have to do here. And I can make this a little more complicated. I could take a monomial and multiply times a trinomial. Same process, multiply each term. Like so. So that's pretty straightforward. That's just distributive property. But now, as we're getting into higher levels, we might have a situation where we have, let's say, a binomial times a binomial. And so we need a process now of how to do this. There are many different ways that you can do this, and you don't need to know them all. Just kind of pick which one that you prefer and do that. The first, for me, I just use distributive property. So if you have something other than just a monomial in the front, you need to multiply each term separately through distributive property. So I would do here x times x, x times -6, and then I'm going to distribute the 4 and do 4 times x, and 4 times -6. If you have something other than a monomial being multiplied in, you're going to need to combine like terms. So for instance here, the -6x and the 4x could be combined. So my answer will be x squared minus 2x minus 24. As you're getting into the larger polynomials with multiplication, the practice is really just basically looking into how can you remember to multiply each pair that you have to do? So there's a couple techniques for that. One is what's known as the FOIL method. So let's write another one here. And so FOIL stands for first, outside, inside, and last. Okay, so this is just another way of remembering what you have to multiply. So if I'm using the FOIL method, I'm multiplying the first two terms, so 3x times 2x. Then I'm multiplying the outside terms, 3x times 2. Then I'm multiplying the inside terms, -1 times 2x. And then the last terms, -1 times -1 times +2. Once I do that, I'm going to combine like terms. And that's my answer. So as we're getting into larger polynomials, what you need to remember is that however many terms I have in each polynomial, if I take that product, that's the number of terms I should get in my final answer before I simplify. So for instance, here, we were doing a binomial times a binomial, 2 times 2. I should end up with 4 terms, which is what we got. So if I give you, let's say, a binomial times a trinomial, then there should be 6 terms before we simplify. You can use distribution like we did here. You can try to do FOIL. It's really a matter of preference. Another way that is commonly taught, and if you had Mrs. Weschler last year, this is something that she did, where use the box method. So basically what you're doing is you're creating a multiplication table. So you write one polynomial going down the left-hand side, and you write another polynomial going across the top. So for instance, 2x minus 7, I'm writing down. And then I'll write the other polynomial, 3x squared minus 2x plus 1, going along the top. And then you're just going to multiply each product just like you would a normal multiplication table. So 3x squared times 2x, negative 2x times 2x, 2x times 1, and then go across on the second row, 3x squared times negative 7, negative 2x times negative 7, and negative 7 times 1. The nice thing about the box method is that when you do this, all of the like terms will line up diagonally if you're looking at the same product. So all my x squared terms are on that first diagonal, all my x terms are on that second diagonal, and then it makes doing the combining like terms a little bit easier. So I have here 6x cubed minus 25x squared plus 16x minus 7. So it's just a matter of preference which of these methods you want to do, any or all. The big idea here is that you need to remember that each product has to be multiplied with each product, polynomial by polynomial. Same thing would be true if we're doing more than 2, but we'll save that for another lesson. That's it for today, guys. If you have any questions, please reach out to me. Otherwise, I will talk to you soon. Bye.